Hello students, let's start part 4 of electricity with our topic electrical resistance. In previous chapter I have told you about electrical resistance definition wise. Now let's see properly what is electrical resistance. So here on the screen you can see picture in which a hand is stopping charges and electric voltage is pushing them and electric current is flowing. So, what is electrical resistance? This is obstruction in the flow of electric charges. So, this electric voltage make them flow. From the picture it is clear. Now, let's see what is electrical resistance. So, by its definition, the electrical resistance is defined as the difficulty occurs in the flow of electrons. The conductor has free electrons. When the voltage or potential difference is applied across the conductor, the free electrons start moving in the particular direction. During the movement, these electrons collide with the atoms and molecules of the conductor. The atoms or molecules create the obstruction, and this obstruction is your resistance. So, it's create the obstruction in the flow of electrons. This obstruction is called resistance. So, what it is saying? It is saying the electrical resistance we define as difficulty which occurs in the flow of electrons. Conductors, every conductor is having some free electrons. Then the voltage or potential difference is applied across the conductor. It releases free electrons when it start moving in the particular direction towards positive terminal. During the movement, these electrons collide with the atoms and molecules of the conductor. The atoms or molecules create the obstruction in the flow of electron. This obstruction is called resistance. So here in the picture you can see free electrons are randomly moving, and metals, and due to this metals and they collide with each other, and due to their drift velocity it's moving in a different, means it changes their speed, and this is only resistance. This is called resistance when they collide with each other. So more number of metal ions, more number of positive charges, more will be the resistance. How we provide electrical resistance to the circuit? Through resistors. The resistance shows the relation between the applied voltage and the flow of charges. The resistance is inversely proportional to the flow of current. How we show this? Inversely proportional to, so we write V is equal to I R. So resistance is inversely proportional by this relation. It is inversely proportional to the flow of current. Unit of resistance is ohm. Bigger unit is kilo ohm, and then we write like milli ohm or micro ohm, like this smallest unit. A wire is said to have a resistance of 1 ohm if the 1 ampere current is passed through it. Law of resistance, what it says, every material must possesses resistance. Every material, some are having low resistance, some are having high resistance. So the material which has good conductivity have low resistance, whereas the material which has low conductivity has high resistance. So we use, for measurement, we use ohm meter, measures the electrical resistance. The ohm meter is connected to the terminal of the circuit whose resistance is to be measured. The resistance box gives them resistance, and ohm meter measures its resistance. So the resistance of the wire depends on the following factor. These factors are: the resistance of a wire is directly proportional to its length. The resistance of the wire is inversely proportional to its area of cross section. So resistance is directly proportional to its length, and resistance is inversely proportional to its direct area of cross section. A, or you can write small a, here it is given, it is same. So what formula we are getting from this? R is equal to rho. This is specific resistivity, or you can say resistivity of a wire, rho L by A. So This is your formula, or vice versa, you can take out rho, value of rho. Rho is equal to R by L, where rho is the constant of proportionality, also called the resistivity of the wire material. The values of rho depend on the nature, atomic structure of the material. The resistance of the wire depends on the nature of the material of which the wire is made. The resistance of the wire depends on the temperature of wire. Remember, resistance depends on its nature, length of the material, and resistance of the wire depends on the temperature of the wire. Resistivity of the material, if we're talking about resistivity, so from definition, resistivity refers to the ability of the substance to resist the flow of current. Its ability, resistivity is what? Its ability refers to the ability of the substance to resist the flow of current. The resistivity of the material is defined as the resistance offered by the 1 meter definition. If we give length of wire of given area having an area of cross section of 1 square meter, the resistance of the wire is given R proportional to L by A. So what you can say, in place of wire, if a cube of the 1 meter side of a given material is taken and their two opposite faces are considered, then the resistance should be R is equal to rho. If L is 1 meter, A is 1 meter, then it automatically it will be R will be equal to rho. When what happen if is equal to R is equal to rho, hence the resistance offered between the two opposite two faces of the 1 meter cube of given material is called the resistivity of the material. So it will be same. So it is called resistance will call resistivity of the material. But for unit length, resistance of the wire is given by the equation R proportional L by A. Also from the above equation we get this relation, important one, remember this. It is measured in ohm meter. Factors affecting resistivity is the resistivity of a substance does not depend on its length or thickness. Remember, it depends on its nature and temperature. Remember this also always. This is important line. Substances which have very low resistivity are good conductors of electricity. This you have to remember. The substances which have very low resistivity are good conductors of electricity. Conductors, those substances, what are conductors? Those substances which have very low electrical resistivity are called conductors. They are very good conductor if their resistivity is low. What are resistors? Those substances which have comparatively higher electrical resistivity are called resistors. What is insulator? Those substances which are infinitely high resistivity, उनसे भी ज़्यादा resistivity है, means very low, are called insulator, and they are not good conductor, like glass, plastic, wood. The electric current is the flow of electrons through a conductor. So the electrons, however, are not completely free to move within a conductor. When the electrons move from one part of the conductor to other part, they collide with each other and with the ions present in the conductor, which I have told you earlier, same line. These collisions slow down the speed of electron. This property of conductor, which by the virtue of which it opposes the flow of electron, is called your electrical resistance. This property which opposes the flow of electron, this is actually your electrical resistance. Example, your question is given: when a 12-volt battery is connected across an unknown resistor, there is a current of 2.5 milliampere. Here you have to change milliampere into ampere in the circuit. Find the value of resistance of the resistor. So volt is given, it means potential is given, current is given. So you can apply Ohm's law. Ohm's law I will tell you after this. Ohm's law is only for definite values, means not for variable potential difference or variable resistance. Here given V is equal to 12 volt, I is equal to 2.5 milliampere. So by Ohm's law, you change milliampere into 2.5 in 10 to the power, it is actually you are changing current value 2.5 into 10 to the power, it is 3. Okay, and R, you will get R is equal to, it is 10 to the power 3 ohm. 4.8 into 10 to the power 3 ohm. Ohm's law. Let's start Ohm's law. Remember this picture. Whenever you see this picture, you will remember Ohm's law. Ohm's law, he has given three things like voltage, current and resistance. He has told us relation between all these three. Here voltage, it's or you can write V or E. We show like this. So if two will be known, you can calculate other third one, unknown quantity. If these two will be known, you can calculate this two quantity. So this is Ohm's law. This pyramid you remember always. What is Ohm's law? Ohm's law is a formula used to calculate the relationship between voltage, current and resistance in an electrical circuit. Don't confuse between resistance and Ohm's law resistance. They both are different. Ohm's law resistance is always definite. You can calculate it, it is already given, but their resistance means it can be variable resistance. So Ohm's law, V is equal to IR. This relation is your formula of Ohm's law. How we spell? When spelled out, it means voltage is equal to current into resistance, and to volt you can write ampere into ohm. Named for German physicist George Ohm, 1789 to 1854. Try a few sample calculations based on a simple series circuit which include just one source of voltage, battery and resistance light. Two values are known in each example. Use Ohm's law to calculate the third. See example. Voltage E and resistance R are known. So what you have to calculate? Current. Current you have to calculate in this formula. V is equal to IR. Keep the value and calculate the third unknown value. What you will get? I is equal to V by R. So you will get 2 ampere result. Third example, voltage and current are known. So third one is resistance you have to calculate. So put the value. R is equal to V by I. It is E by I, or 24 volt by 6 ampere. You will get 4 ohm. Third, current and resistance are known. What is the voltage? I is equal to 5 ampere. R is equal to 8 ohm. E means V is unknown. Here V is unknown. So calculate it and keep in the formula and directly calculate. You will get V is equal to IR, so you will get 40 volt. When Ohms published this formula in 1827, his key finding was that the amount of electric current flowing through a conductor is directly proportional to the voltage imposed on it. In other words, 1 volt of pressure is required to push 1 ampere of current through 1 ohm of resistance. So this is what your Ohm's law. It is showing normal conditions should be constant for Ohm's law, then only it will apply. Otherwise if temperature will be vary or other thing will be vary, Ohm's law will not apply. This is the limitation of Ohm's law. Thank you.